So, hello everyone. Today, we're going to talk about Fourier series. So, yeah, this is a mathematic topic. So, without wasting much time, let's start. So, www, not World Wide Web, but what, why, and who. So, what's Fourier series? Infinite series of trigonometric functions which represents an expansion of or approximation of a periodic function used in Fourier analysis. And John Baptist Joseph Fourier. He was the one who created the Fourier series or who found the Fourier series. It is used to determine the heat equation in conductors that can conduct heat. And this heat might be so low or so high that it cannot be measured using instruments. You won't get the accurate results. So this is where Fourier series is used. Let's move on. So what is Fourier series? Taylor series, representation of functions which are continuous and differentiable. But there are many discontinuous periodic functions which requires to express in terms of infinite series containing sine and cosine terms. Therefore, Fourier series, infinite series representation of such functions in terms of sine and cosine function. So there are functions which are continuous and differentiable. But this kind of function can be represented using Taylor series, which you might have studied. But there are certain functions which are discontinuous. That means the limits are too high that it cannot be calculated. So, and these functions contain sine and cosine terms. So such kind of functions are such kind of functions are not simplified using a Fourier series. So this is the blue highlighted equation. This is the Fourier expansion. So this is f of x is equal to 1 by 2 a naught summation of n to n equal to 1 to infinity a n cos nx plus summation of n equal to n infinity bn sin nx. I'll tell you what a naught, an, and bn is. So you see a naught, an, bn are the coefficients, and n is the positive integers. This n, of course, n tends, the limit of n is fixed for Fourier series. Most of the time, at least 95 or 99% of the times, it's n equal to 1 to infinity. So a naught is a coefficient. This is the value of a naught, 1 by pi, integral of minus pi to pi, f of x dx, and a n, 1 by pi, minus pi, integral of minus pi to pi, f of x cos nx dx. And bn is 1 by pi, integral from minus pi to pi of f of x sin nx dx. So just remember the values of a naught, a, and bn. We'll tell you how and where to use it. My bad. So condition of Fourier series, f of x is bounded and single valued. A function f of x is called single valued if each point in the domain it has unique value in the range. F of x has at most a finite number of maxima and minima in the interval. F of x has at most a finite number of discontinuities in the interval. So as we said, if the function has the least number of discontinuity, or it is continuous and differentiable, at such cases Taylor series is used. But since we are using Fourier series, this means that the function has a lot of discontinuity. Example, let's take an example. Sine sine minus 1x. We can say that the function sine minus 1x can't be represented as Fourier series, as it is not a single valued function. Tan x, also in the interval of 0 to 2, cannot be expressed as a Fourier series because it is infinite at x equal to pi by 2. So even or odd Fourier series. So when you evaluate Fourier series, the function might be an even function or an odd function. So how would you know that if a function is even or odd? These are the conditions. So if the limit is given from pi to pi, or which is in terms of pi, then you calculate, or even in terms of L. So here we have taken the example of a function which has the limits of minus L to L. So if the function is given in these limits, then you take it as f of x is equal to f of minus Lx, or f of minus L, where L is equal to the limit. Now f of x is equal to a naught by 2. So this is the Fourier expansion for even function. Similarly, with the similar way, you find out whether a function is even or odd. If the function f of x is equal to f of minus x, then the function is even. If the function f of x is equal to minus of f of x, it's no. If the function f of x is equal to f of minus x, then it's an even function. And if f of x is equal to minus of f of x, or f of minus x is equal to minus of f of x, then it's an odd function. This is the Fourier expansion for even function. You can see that the sine term has been eliminated over here. And for the odd function, the cos and the a naught term has been eliminated over here. You can see that the bn is equal to 0. Over here, a naught and an is equal to 0. And that's the reason the terms have been cancelled out. Let's take an example, x squared plus x. So we know that this is the Fourier expansion. So first we need to find out the values of a naught. So a naught is equal to 1 by pi minus pi to pi f of x dx. We integrate this equation and put in the values from minus pi to pi. We get 2 pi q by 3. So this is the value of a naught. Similarly, an is equal to 1 by pi minus pi to pi f of x cos nx dx. One more thing that we need to add here, but we forgot, is the Bernoulli's theorem. So when there are two terms in the integral and the two terms are a product of each are in the product form, we can use the Bernoulli's theorem. I'll make sure to add it. So by using the Bernoulli's theorem, this is the integrated form of x squared plus x into cos nx. By replacing the x term with the with the limits, that is minus pi to pi, we get an equal to 4 into minus 1 to the power n by n square. Here minus 1 to the power n represents cos n pi. So whenever you get cos n pi, it is converted into minus 1 to the power n for simplification. It's convenient. Similarly, bn. So over here we have minus pi to pi f of x sine nx dx. Similar in the same way, use Bernoulli's theorem, and you get the integrated form. Replace the x values with minus pi and pi. You get 2 into minus 1 to the power n pi n. Now replace these values in this equation, which is the Fourier expansion. So when you replace these values with Fourier expansion, this is the final Fourier series that you would get. So cos nx minus, you can see that x squared plus x is equal to pi squared by 3 plus summation of n equal to n to infinity, and 4 into minus 1 to the power n by n square cos nx minus 2 into minus 1 to the power n by n sin nx. So this is a summarized way, or a short way to understand what Fourier series is. We'll talk about it in detail in the coming up days. Until then, thank you.